So welcome to the May meeting of the New York JavaSIG. Tonight we have a great speaker, Billy Carando from Oracle, to talk about Java Flight Recorder. But just a few announcements first. So tonight we have our usual IntelliJ raffles. I think at this point, everybody has won. And we also have a bunch of books. They're not here. So ChatGPT for Java developers, it just came out. So the author has, in Press, the publisher, has kindly offered to give us about 8 copies. So we could donate those, or we can raffle those off. And also Venkat from the Dev2 Next conference has given us a discount, which I'll mention at the end. So let me introduce Billy. Actually, before that, does anybody have any open questions on Java or anything Java related? Any open question, anything that's burning you want to know about Java? Not even one? Wait a minute. Is this the Java group or the Java group? Question over there. What programming? CUDA program. That's a good question. Well, there's J CUDA, right?
Just add J in front of it, and there you go. You're good.
Or 4J.
Or 4J, yes. Yeah, J in front or 4J after. So.
But that's an interesting question. I was talking to someone today about AI in Java, and there's new hardware from NVIDIA that there's a new API, new library that they have for that uses their new Tensor Core processor. I don't think that library is available yet, but that's the direction they're going in. I think most companies are going to these sort of so-called Tensor Cores as opposed to GPU things in the future.
I'm curious which version of Java people use.
What version of Java are people using? Okay. Who's using, let's see, how do we phrase this? Who's using Java 8 in production? Who's using Java 11 in production? Who's using Java 17 in production?
Oh, nice.
You
mean 1 and 21 yet?
Yeah, 21.
Nice.
In production? Yep. Nice.
What about 22? Yeah. 23 EA. Oh, okay. I guess we don't have any really brave souls here. So all right.
Okay. If there are no other questions, let me introduce Billy. So Billy's a dev advocate at Oracle for Java. He's in the Java platform group. And again, thanks to Oracle for the pizza. Nice Oracle, yes.
Yeah.
Also, thank you to Bank of New York Mellon for giving us the room, beautiful room here. So thank you, Bank of New York. So Billy has over a decade of experience with Java.
Yeah,
wow, nice. And Billy brings a passion for helping developers reduce tedious work. Always a good thing.
Yes.
Such as project initiation, deployment, testing, and validation through automation and adopting the latest features and tools. Very, very cool. So outside of work, it's known that Billy is a Kansas City Chiefs fan.
It's a good time to be a Chiefs fan.
Is that the team that Taylor Swift's boyfriend plays?
Yes, it is.
Well, here's Billy.
Thank you. All right. Thank you for that introduction, Frank. And thank you for inviting me to come out here to present at NYJavaSIG, the oldest Java users group in the world. So that is quite something. I'm actually surprised. I think the St. Louis Java users group is supposedly the second oldest, or at least that's what they claim.
St. Louis, really?
Yeah, which is kind of, I'm going to be pretty surprised about that as well. But at least that's what they claim. But yeah, with that said, yep. Billy Carando, Java developer advocate with Oracle, but don't hold that against me. And we're here to talk about taking off with JDK Flight Recorder, or probably more commonly known as JFR. So the important information, if at any point, please feel free to ask questions. Done this presentation now. This will be the 3rd time in 3 days I've done this presentation. I kind of have it down pat. Even before then, I had it pretty on lock as well. So feel free to ask questions at any point. You're not going to throw me off or anything like that. And plus, it being a users group, I don't think we have any hard stop or anything like that. Or at least we're not going to get into any sort of, we're not going to be here till 10, something like that. So we'll be good. If you do have a burning desire to know some more information, so my team over at Oracle, we have a lot of great sites to go to, or great sources of information. So we have dev.java. So that's a website that my team has put together, and we have a lot of great tutorials, including on JDK Flight Recorder, along with a lot of other great tutorials. And we've also recently opened it up to community contributions, and we've even had some really great people like Venkat Subramaniam. Has anyone heard of Venkat? Yeah, a few people. Pretty good guy, knows a little bit thing or two about Java, but he's also published a couple articles on there. So great source. Insight.java, that is where a lot of the JDK engineers, if they put a post out onto their blog, or sometimes they post directly to there, we'll link to that as well. So that can be really great. For example, with some like the actual engineers that work on JDK Flight Recorder, if like they're adding a new feature, they may have like a short article that we link to on there. And then we have our YouTube channel and also the Inside Java podcast. So for the agenda, we're going to briefly at a high level cover what is JDK Flight Recorder, and then from there we are going to get into a live demo that's going to involve configuring and using JDK Flight Recorder, how to analyze results, and then creating custom events, and then using JFR event streams. So what is JDK Flight Recorder, or as I'm going to be more commonly referring to it now as JFR, because I don't want to have to be constantly saying JDK Flight Recorder. So JFR's history actually goes back quite a ways. It was initially added into the Hotspot JVM, which I'm imagining pretty much everyone here is using the Hotspot JVM or some derivative of it back in JDK 7. And initially that came from, and then it was called Java Flight Recorder. So if you heard Java Flight Recorder before, that's referring to the same thing. And you can see in the next bullet why that name changed. But JFR goes back even farther. So originally it was developed by JRocket for their JVM implementation. And then JRocket, which was ran by BEA Systems, was bought out by Sun. A bunch of mergers all happened. And so that is why it's now part of the Hotspot JVM. So some of the really important things, I was happy to see that the vast majority of people here were on a distro later than JDK 8 in production. So if you're on 11 or later, you can use JDK Flight Recorder in production without needing a production license. So before JDK 11, you would need to use like enable commercial features, enable Flight Recorder before you can then actually enable and use it. If you didn't turn that on, I am an authority that like a little like SWAT team of like Oracle lawyers would just like burst through the window and carry you away. But yeah, no, so you can use JDK Flight Recorder now in production without needing a license at all. And the other really nice thing is that JFR is built directly into the runtime. As I kind of mentioned before, it's built directly into Hotspot. So to start using it, you don't need to go out and get some other binary or some other library or something like that to actually use it. It's right there if you're again having some sort of Hotspot distro. So that would be Oracle OpenJDK, Oracle JDK, Azul, Adoptium, Corretto, Microsoft's distro, Red Hat. Those are all using Hotspot or a derivative of Hotspot. So they would all have JDK Flight Recorder already built in. So JDK Flight Recorder is a event-based diagnostic and profiling framework. So some of the really nice, or some of the key benefits, like some of the things that absolutely needed to have, is it has an extremely low overhead of under 1%. And the reason for this, it's meant to be used continuously in production. And it also needs to be a good tool where you can actually measure the performance to make sure that you're actually meeting performance goals. Like the actual JDK engineers really do use JFR as a means to test their changes that, when GC engineers are making changes to G1, GDC, Parallel, or the other garbage collectors, they're often going to be using JDK Flight Recorder to, kind of measure like, okay, are we hitting our pause time goals? Are we hitting, making sure we're reducing, keeping within our heap goals and stuff like that? They're going to often be using JDK Flight Recorder to measure those results. It's also meant to be continuously used in production. So again, another important takeaway is you should really consider actually taking this and starting to use it actively in production, because it has a very low overhead. And what can be really great about it is that if you do run into some sort of issue that at like 2 a.m., all of a sudden like your application just pukes or something, you could actually get these recordings and maybe get an idea on what went wrong. Or maybe you have like an occasional issue where every 17 hours for some reason the application just really slows down. You have no idea why. Again, being able to have JFR recording there and going back and reviewing those logs, you can be like, oh, okay, what is going on here? You can actually maybe track what's going on there. Additionally, JFR, it covers both what's happening within your application and then also in the JVM as well. So it's covering a very large area of what is happening. It's not just like, oh, looking at like this very narrow area that might not be particularly relevant. Yeah, so the under 1% overhead, that is when using default settings. By default, our JFR comes with 2 setting files already pre-configured. Default, which, as its name suggests, is the settings that would be used if you don't otherwise specify. They also have profile settings, which gets up to about 2%. You can also supply your own kind of custom settings, and we'll get to that later. The important takeaway when it comes to that, though, is the biggest thing that can impact performance is the amount of the stack you're capturing. Because if you're really capturing a large part of the stack, that's going to start taking up a lot of memory trying to capture all of that. So that's just like the only thing to kind of keep in mind, is you don't want to be like capture everything for everything, and then you might actually start to run in a noticeable performance impact. Under the hood, as I mentioned, events are improved both by the Java runtime and then the application. And then they are stored in local thread buffers. And as those get filled up, they are then dumped into a JFR file. And actually, a little bit later here, I'll show a little slide I've put together to kind of visualizes what this behavior is. There's a lot of different events in JFR. I need to get this slide updated, because I think when I first wrote this presentation, it was JDK 18, and around that time they just got over 150 events, but I think they're closing in to like between 180 and 200 predefined events. So like I said, it's covering a very large amount of behavior, and we can see here like garbage collections, writing to threads, or writing to files, reading and writing to sockets. So it's covering a very broad range behavior within JVM and the application. That said, this is very much a live action demo, so let's go ahead and actually start slinging code. Yeah, it's probably way too small. Is that big enough then for everyone, even in back, or do I need to get bigger? Okay. So at the most basic level, you can just simply start JFR with XX : start flight recording. Now, this is unsurprisingly not necessarily what you want to use in production, and we'll get into that a little bit later, but you don't necessarily have to do a whole lot of work to get it working at a very basic level. And so once you start it up, JFR will kind of print out these lines, and using the JCMD tool, you can command JFR to dump the files, the information that's accumulated, into a file. So if I go into another, shrink that down just a little bit. So yeah, if I go into another terminal here, and I do NYJavaSIG.jfr, that will have dumped out the behavior that JFR has observed within the Spring Boot application. And you can see, just simply starting, all we did was just start up a Spring Boot application, in this case using Spring Boot Pet Clinic, which is a demo application the Spring Framework team put together. it produced 1.6 megabytes of information. So JFR does produce quite a bit of data. Now, there's many ways of kind of inspecting that recording. So I'm going to first kind of go over ways of doing it with the command line. So there is the JFR tool. And so there's many different options for kind of observing what's within it. So first going to look at using JFR summary. And as that name suggests, that gives you an overall summary of all the different events that occurred within the application. And so where this could be very, very useful is obviously you can see a lot of events occurred here. Is if you're looking for specific events, particularly maybe have like some sort of custom events that are happening, you can kind of see here, like if you, so in this case, like I have my custom my event that occurred one time. Maybe also have some other events that you're tracking database transactions that you created. You can be looking to be like, okay, wait, have any of these database transaction events occurred? So that can be useful here. Now I can then further kind of inspect these events if I was to turn this down a little bit. So yeah, then using the print command, I can give it like a list of events, and there's other ways you can also filter for specific events you want to look at, and then it can actually say what occurred with this event. So what the, these commands are really good for is if you're looking for a specific issue. So like you have an application, you understand it really well, but like maybe it's occasionally running into some sort of issue. Again, maybe like a really good example where you created like some sort of event that's measuring database transactions, and like 99% of the time those database transactions they execute in under 10 milliseconds or whatever is within the target. But then that 1% of the time, all of a sudden, like it kicks up to like 2 seconds or something that's executing, or it's taking a minute to execute. This can be a good way to drill down to like those specific events. You can see is like, okay, they're occurring at about 5:49, or it's always occurring around that time. Maybe what's going on, and you find out maybe like the database people are doing maintenance around that time, or you could. It's a way to kind of easily drill down, and the particular benefit here is you can do it within the like you can SSH into that box that is running that Java application, so that way you don't necessarily have to download the JFR file. In this case, obviously using a test example, it's only 1.5 megabytes, but in a more real world setting, it could be easily tens, hundreds, even gigabytes in size, in which case bringing that down all the time could be quite time consuming and costly potentially. So being able to use command line tools to maybe kind of inspect some of this stuff can both save you time and just, save you time is always good. One thing that's really nice that has been recently added to JFR, the JFR tool is view. So like here, we're getting just, very generic information, or drilling down to very specific areas within it. But I think this was JDK 21 is when they added these view commands, which can give you a bit more of a holistic view into what is happening within your application. So NYJavaSIG and oh, need to be on the correct version. So like here, there's just like a thread count view, and it's showing obviously the number of active threads and peak number of threads and so on that's occurring at different times within your application. If I was to do JFR view, it would show you a bunch of the other commands. A really good example would be something like hot methods. So like this would be showing obviously which methods are being used the most within your application. So this is a way of giving you maybe a bit more of a holistic view into what is happening within your application, and without with that you can also do from the command line. In a future version, the JFR team, they are looking at creating a query. So like right now, there is about, I think it's like 50 or 60 different predefined views they have available. But they're looking at creating like a query language you can use for this view. So where it's like, okay, I want to look at the number of views and then look at which threads are using which methods or something like that. So they're looking away, creating some sort of a query language to create these views. Hopefully that may be coming to 23, maybe 24, but at some point. Another important key takeaway though is, so like here I'm using JDK 22 within this terminal. But this application that I'm running right now is actually running using JDK 17. So like this view tool, I think it was again added in JDK 21, and maybe you're on 17 or 11 or something. You don't need to be running JDK 22 to be using these view tools or a lot of these inspection tools to view your application. JDK Flight Recorder has really great backwards compatibility that it can read back all the way to JDK JDK 7 U40. So yeah, if I was running the Spring Boot application with JDK 7, which I couldn't in this case because it's using a version of Spring Boot that needs JDK 17, but all the same, I could still be using these view commands and summary commands. And we'll see here in a moment JDK Mission Control to inspect it as well, even though it's a very new version of those. So yeah, those view commands, the view and summary and all the command line tools are great because you can, again, SSH into a remote terminal that is running it, so you don't necessarily have to download the files. But if you are just wanting to get like a holistic view of your application, one of the best tools for doing that, or at least a free tool for doing that, is JDK Mission Control. So I think someone was, during the Java Day earlier. So JDK 8 or yes, technically JDK 10 and before, but JDK 8 since no one's, I hope no one's using JDK 9 or 10 in production right now. But JDK 8 and before, JDK Mission Control was packaged into the JDK. But as I was mentioning before, in JDK 11, we open sourced JFR. And so, of course, as I mentioned, JFR is still built into the JDK. But we took JDK Mission Control out of the JDK itself. So it's a separate the binary they have to download. But it's open source and still free and still supported as well. So, and also, as mentioned earlier, we just had a new version of JDK Mission Control released. So I'm using JDK Mission Control 9 here. And that does require JDK 17 to run. But as mentioned earlier, you can inspect if I was running my Spring Boot application with JDK 7 or JDK 8, I could still read the recording file. I'm going to open here in a moment. Oh, there it is. So here on this first page, it is the automated test results. And so what this is they built like a rules engine that can inspect the JFR file and can see all the events that occur and kind of just give you a high level overview of maybe some things you should consider looking at that could be areas of concern. So like it's saying 25 parallel threads are executing. So I guess it's sort of fine, but it's saying like a little bit of concern here. Apparently within Spring Boot, it's throwing a bunch of errors when starting up. So like it's 9.5. So like, that's something I would maybe want to check. So like I said, it's particularly if you're writing a new application or you're doing like a major refactor of an application, this can be a good first page to kind of go into to kind of give you an idea of maybe some things you should be considering to look at. From there, you can see that there's like this outline as like 3 major segments, and it's kind of roughly in, going down the stack of the Java application at the top, where it can show you like the CPU usage, heap, method profiling, and so on. Then it goes to JVM internals, which is obviously covering stuff that's actually happening within the JVM itself. And then also finally into the environment, where it can, you can see environment variables, so you can make sure that you're actually using the expected JDK version. You're not using like, oh, well, of course, we're not using the correct JDK version. That's why we're running into this error. So this is also a good way just checking to make sure you're using all the correct behavior, because how often have we done that where you're starting something up and you didn't realize you configured it correctly, and then that's why you're not getting your expected results. Similarly, also up here under JVM internals, it will also show you like the configuration you have set up for your garbage collector. But like other great areas that can be good for, again, if you're working on the performance of your application, would be like here, method profiling. And maybe there's like some sort of method you see all the time in your code, and because you see it all the time in your code, you're like, okay, well, if I want to improve performance, I should probably call this method that's going to be called all the time. But if you actually go in here, you can actually see the amount of CPU usage that maybe individual applications are going. So even though, let's just say hypothetically, I was calling copy of from arrays, from Java util arrays, is being called many times within my application, but the CPU usage is only under 1%, well, then that can tell me is like, no matter what I really did to improve those calls, you're not going to really see much improvement in performance. Whereas if, I improved how I'm calling check jar up here, again, this is all happening deep within like the framework. So, this is not really my code that would be changing. But, it's taking up 42% of CPU usage. So obviously there's a lot more benefit to improving it there. Yes.
Well,
Looking at the numbers there, I'm not sure I believe that percentage is a percentage of CPU usage.
It
looks like it's a percentage of the total number of counts.
Well, I mean, it's a little bit off. I think it's just because
there's probably not 100 actual counts if you add them up. I guess it's a little more than 100, but
yeah.
It's all the ones take exactly the same percentage time.
Yeah, so if I probably ran here another dump, I think this is just because of maybe not the best, a large enough sample size. So let me do another dump here. It should probably have hopefully gotten a bit more, and reopen it, and it should look different. So yeah, I mean, at least it's a little bit different here. And I can run another example later on where it's not just the count and the percentage are pretty close together. Like it would be, many thousands within the count.
Well, that could be, but it's still the case that it's not a percentage of the CPU time being executed here. It's a percentage of the number of counts that have been taken. Yeah.
Yeah. Let me. Yeah, I hear what you're saying. Let me actually then. And I mean, that's also going to be at least a little bit of the result of the thing that's going to be executed the most often is also likely the thing that's going to be taking up the most memory. So yeah, this is the almighty do stuff command that I have in there that's just doing a lot of stuff. And so if I did another dump here, okay. So you can see here that now that the count and the percentage aren't, I mean, again, because this do a lot of stuff is being called a whole lot, and there's a lot of stuff going on within it, it's going to be taking a lot of time up. But you can see there's not that relationship of, it's executed 40 times and its percentage is 40. And this should be, I should say, this isn't overall CPU percentage, but CPU percentage within what's actually being used by the JVM. So like the JVM CPU time is 28% of it. Are you
No. I mean, look at all the cases of the things that execute once each. All of those have exactly the same percentage, and there's
see
no
what-
way that all of those
I see what
are
you're saying.
taking
exact
exactly the
same
same
amount of time.
CPU time.
Yeah, that might actually be a bit of a bug within their application. That's a good point. Actually, I should pass that along back to the JDK Missile Control team. Good point. Though it's still kind of give you shit. That is a good
It'll
point.
tell you how many times things are called.
Yeah,
It's called most often.
that is a good point. I didn't notice that before. I'll bring that up with the JDK Missile Control team. That yeah, they're clearly, yeah, you're right. They're just doing that math based upon the number of times it's executed. And good point. that does seem to be a bug. All right. Yes.
So is it possible to run J command, JCMD on a remote machine?
Yes. I guess I haven't really done that as much. I just do mostly a proof of concept, but you are able to run it. I do have a link at the end of this presentation of a team where they are using JDK Flight Recorder on a Kubernetes. And I think they actually kind of go through that example of remoting into like a Docker machine or a Kubernetes cluster.
I have a long question. Should I ask now or wait?
Yes, go ahead. Okay. Good. Yeah.
Okay. So I have a startup.
Uh-huh.
And we have a Spring Boot app that's load balanced on 3 servers.
Mhm.
And one of the things I'd like to do is, for example, I'd like to be notified when one of my REST calls takes longer than some maximum time.
Yeah.
And when that happens, tell me why. Was it too many threads running at the time? Was it database connection that was slow? That kind of thing.
Yeah.
Is that something?
So yeah, so something you can do with that, and that's getting a little ahead of work, but no, that's fine. I'll go ahead and answer that or cover that now. Is I'm using this in a test context, but this was added in JDK 14. There is JFR streams. And so this is a way of programmatically getting into the JDK Flight Recorder to see events that are occurring. And you can sit here and say, okay, so like you're having like a REST call. So you would create your own. So my org, REST event or something. And so where that REST event is happening within your code, and I'll touch on it a little bit later here, you would have an event around there. And you can set up configurations to where, like, okay, when this event takes longer than whatever time you think it's relevant to execute, it'll be caught in here. And then you can say, like, okay, this event took longer to execute. Now, as far as like why that occurred, I mean, I guess you could technically also kind of read through events in here. But probably what you would want to do is have it alert you when that happened. And then you would probably do like a manual, dump to get out that JFR recording and then kind of look at what is happening that could be causing the event to take so long to execute. You could maybe eventually, if you start becoming familiar enough with maybe why this could be happening, you can maybe add additional logic in there to say like, okay, is heap usage over a certain percent or something, and maybe that's why it's happening, and to check on that. But chances are, at least initially, you would probably be like, okay, we know sometimes this call is taking over whatever our target amount is, and you probably would have to, look at that recording and analyze it in JDK Missile Control, which maybe not always accurate in its reporting, to maybe get an idea of what is actually going on, or maybe get an indication what maybe actually is going on within the application.
Is that try to use the aspect oriented programming, and there are annotation of task as execution time. So just above method, you apply that one. That could simplify his job by capturing that information and getting more accurate information.
Yeah, I mean that is also another option. And I mean, perhaps you could also combine that with JFR if you wanted to as well. But yeah, there are other options using like aspect-oriented programming where you could add some sort of annotation that could also check and alert if something's taking too long to execute. But I'll get to here in like a few minutes, writing your own custom events to where you can again capture some area you want to have timed or some other behavior you want to capture, and how to set it up to where if it goes over a certain time period, to then how you can maybe inform you of that. Yeah.
So there's like a lot of guys use something like Prometheus. I know if you to capture something like this, which has like different level of classification, like metrics. You can do a lot of different. So does this provide something similar to Prometheus, like OLT? There's a telemetry protocol, like entire like a on open source telemetry, which is more about observability of your application.
Yeah. So how you could use it for something like Prometheus, because Prometheus, if memory serves, is just a visualization tool for telemetry data, correct?
No, Prometheus is actually the metric capture piece, right? It captures.
But yeah, it's not generated like but it's a way of taking in data to then kind of visualize it. So it's been a while since I last used Prometheus, but using like JFR tools with like print, I think you can configure it. So you can print it. You can have it print out as JSON or XML. So like the default format for a JFR recordings is kind of it's a non-published spec. So it's not proprietary because JDK is all open source, but it's not really published, and they do that so they can keep it as dense as possible. But you can set it up to where you can take out recordings, export it out as XML or JSON, and then read that into Prometheus. And I'm guessing there's probably already utilities set up to do that within Prometheus. Okay. All right. Any other? Great. No, again, please ask questions at any point. Sometimes we may be jumping a little bit ahead, but we'll eventually also get to cover some of these areas in more detail. So far in the example I just did, I was just running start flight recording without any options. Unsurprisingly, this is not what you will want to actually do in production. Not for the smallest number of reasons is that the default settings for flight recording is just to capture all data and hold it indefinitely. And if you actually have a production application going that's getting any amount of traffic or usage equivalent, that could quickly end up being to many gigabytes or potentially terabytes in size if it's running for long enough. So you would actually want to configure JFR to have a limit on how long you retain data for. So I don't want to type this all out in fat finger something. So I will go to my handy dandy cheat sheet here. Okay, so obviously here, what I'm telling it to do is before when I was commanding JFR to dump, like I was given in a file name, but now I just will tell it to always just, when I execute it to dump, it will automatically just give it the name of NYJavaSIG recording. But the important things here would be the max age and max size. In this case, I'm doing it for a max age of 5 minutes and a max size overall of 10 megabytes. And actually, I do need to now open up this. Just to give a bit more of a visualization of what is actually happening here. One moment. So to give a it's not what I want. So what is happening here, or how JFR runs, is so like within the application, the underlying JVM, as events are propagated, they are initially written to in-memory thread local buffers. And these are pretty small, like they're only maybe like a meg or a few 100 kilobytes in size. Once they're filled up, they will go into a rotating global buffer that is over time dumped into a JFR recording file. And so like the recording size of that. And so, but yeah, this is kind of like the overall general behavior of what's kind of like how JFR is kind of recording and writing events. And this will help make a little more sense when I show what's also happening in live code. So like right here where it says max chunk size, that would refer to like those global buffers in size of once they get filled up to, in this case, 2 megabytes, then it's going to dump that into a recording file. And that's going to be stored in a temporary directory, or by default, it will be written to your system's temporary directory. In this case, I'm defining repository to write these to, in this case, NYJavaSIG, so I can more easily locate and find it. But what will happen here is that JFR will, whenever a recording file gets either to be older than 5 minutes in age, or the total amount of data stored is greater than 10 megabytes in size, then it will delete the oldest recording out of that. So that way you just don't have an ever expanding amount of data you're storing up, because as we saw, just simply starting up Spring Boot, Pet Clinic can take up 1 megabyte or 1.5 megabytes. So obviously a production application could be generating a lot of data. Now, of course, in this example, 5 minutes and 10 megabytes, that's way below what you would actually be doing in production. You would actually do 1 day and, maybe 10 gigabytes in size, or, whatever makes sense or is appropriate for your application. So to where you're actually capturing a large enough time period, because you don't want it to be, overnight an application runs into some sort of issue, you get there the next day and then all the data is wiped out. But of course, you also don't want it to where you're just capturing all that data and then your S3 bill goes to the roof. So anyways, I'll go ahead and start this up, and we can kind of see this behavior then in action. Again, execute the all-important do stuff command. And if I go to NYJavaSIG directory, so yeah, I'm telling JFR to write its temporary files into this NYJavaSIG, and then by default, it'll just create another directory that uses the dates. And so if I go in here, we can see here, so once that global buffer reaches about 2 megabytes in size, JFR will cut off adding data to it, but because it's never going to be quite exact, because there will be some still events in flight, it's always going to maybe be a bit over whatever that max chunk size you set it to. In this case, I set it to 2 megabytes. And again, I did that purposely for demonstration purposes. I think the default is like 24 or 50 megabytes in size. So that kind of gives you the idea that, I'm using a very limited example, but in a more real life example, you're going to be using much larger amounts in 5 minutes or 10 megabytes in size. But here in a few moments, so we can see here that the first one is 18_20. And in a few moments here, it's going to hit that 10 megabytes in size, and it's going to end up deleting that first file. So if we give it a few more minutes. So yeah, between that, like it wrote another file, it hit that 10 megabytes in max age for the size of the repository. And so it automatically deleted that first recording file. So again, that way you can have just like a kind of continuous recording of a particular period, and you can do it by age, you can do it by size, you can do it by both, and which I did in the previous example here. But that way you can have it running continuously in production, but not worry about, again, completely overwhelming your storage space. So yeah, there's many options for configuring JFR. So most of them so far, I have been demonstrating configuring that through the VM arguments. And if you go here to, the appropriate, like the Java command, in this case, of course, I'm using JDK. Oh, I guess I'm running JDK 17 for a Spring Boot application, but this is what it is for JDK 22. You can kind of see all of the different options for how you want to configure it. So there's flight recorder options, and that's kind of configuring the behavior for how JFR is configuring or capturing events. And then there is the start flight recording. This is mostly what you're going to actually be configuring, where again, the max age and max size for how long you're going to be retaining configurations. And then the also settings path. So the settings is not Copen, open. Okay, that's right. Oh. So JFR would use settings file, and as you can all well and see, that this is just simply an XML file. And from this, you can configure how you want to handle different events. So there's the enabled. Obviously, if it's true, then JFR will actually capture that event when the conditions for it to be execute are fired. If it's false, then obviously that won't be captured. You probably won't be using this as often, but there's a period to where how often. So like you can say a period like once every minute, when this event happens, we will actually capture it. But if it's been less than a minute since the last time it's been executed, then JFR will ignore it. So like that could be a way of checking on like memory usage. You want to say like once every minute, what's the memory usage of my application? That would be what is period is for. To your question earlier about the RESTful application. So what you'll more often be working with is threshold. And so you're saying like, okay, most of the time, if like this, making this call to our example I was using for a database, or making a call to like some sort of REST service, if it executes in under 20 milliseconds, that's within the target for our organization. Then if it's under that, then JFR will just ignore it. It won't capture the event or anything like that. But if this event takes longer than 20 milliseconds to execute, then JFR will actually capture it. So that is a way of making sure that you're not just capturing a bunch of data that you don't really care about. You don't care about when you're calling a database and it executes in 20 milliseconds. That's fine. You care about when it takes 1 second to execute. So that's one of the more important configurations you care about is the threshold setting. And so, as mentioned before, JFR comes with 2 default configuration files, default and profile. But another nice tool they've recently added is the JFR config. And so it can help walk you our JFR configure. Yeah. So yeah, JFR configure, so it can help walk you through configuring an application. And particularly what's really nice now is they have an interactive wizard. And so you can answer 12 questions here. And if you want to accept the default, you can simply hit enter. And so if I hit this 12 times, then that will be effectively the equivalent of the default settings. But this can be a good way of getting a baseline default settings file, and then from there configure it to like maybe add custom events that you have added. So if I would say again, open up this file. So like, let's say, so I have like my own custom event in here. And if I wanted to configure it, that is a way you can handle that. So yeah, part of the reason this was added is we were finding that a lot of customers would go into the provided settings file and change it, and then they wouldn't be able to get back to like having like a good default file to change. So we added these configuration utilities to make it easier for customers to kind of get their own settings file and go from to configure there. Yeah, Frank?
Yeah, so the JFR files are binary files, right?
Yes, it's a binary format. Yeah.
But the binary format is well-known format. In other words, is there an API to that, or can I write a Java program to read those?
So no, it's like a non-published format. So like it's kind of within the internals of the code, but I've talked to them about it, and it's been a little bit since I last talked to the engineers about it, but it's just, they kind of have like their own custom, it's not a well-known, publicly known format, but it's kind of like their own binary format they put together to make it as dense as possible when writing this data. Because again, as we saw, like it produces a lot of data. But if you needed to read it out, as I was kind of showing earlier, you would have like the JFR print command. And
Right. I mean, to visualize that, I can see that. I mean, so I have a lot of experience with monitoring systems, and with big enterprises, there's a lot of monitoring systems.
Yes.
And you want to integrate this into those monitoring systems. How would I do that?
You would maybe have some sort of utility that could, extract out these, like you would automatically maybe convert it to JSON using like the JFR utility to print it out to some kind of format and then read it in that way. Or alternatively, if you're looking at maybe not just trying to take in everything in, but maybe specific events, you would maybe use using JFR streams here, where you have programmatic access, and you could write it out to some sort of endpoint, and then have your monitoring tool monitor that endpoint to consume those events that are being propagated.
All right. So like, there's a way of doing it. It's just not direct.
Yeah.
Okay. Next.
Yep. Any other questions then? So yeah, to get back to then actually covering events. So yeah, there's already like some 150, 180 or so different events that are already predefined by the JFR team. But of course, you can create your own custom, naturally, to really be very useful, you need to be able to create your own custom events as well. And to create a custom event, at the most basic level, all you need to do is extend the JDK.jfr event. And that's fundamentally all you have to do to create an event. Now, you can also, you probably would want to add your own field types for capturing data. And in this case, like the field types you can capture, it can be string or any primitive type. If you try to capture any other data type or any other field type, JFR will simply ignore it. So like, let's say if I created, my own record type record and, whatever, and I try to write to it, JFR will just simply ignore that data. It won't give you an error or anything. You'll just, I don't recognize this, and it's not going to capture it. But then within your code, you would then instantiate the event type, and then you would call begin, and then within the begin, and you would whatever business behavior, calling out to some sort of RESTful service, calling out to some database, or whatever you're doing, you would have that code there, and then you would either call end, and then of course that would end the timing of the event. And then if there is maybe some sort of calculation you need to do when writing stuff to that event type, in this case, like I'm just saying like, oh, okay, some very important, valuable data is being captured. Not maybe the greatest example. You would do that here, and then you could call commit. But also, if you wanted to, you can just call commit directly. If maybe you're just simply timing it, or maybe the data that you're writing to that event is pretty simple. That's not going to take too long to execute. So yeah, the calling end, you would maybe only do that if you have some sort of complex behavior that can maybe take some meaningful amount of time to execute, and you don't want that included within the timing of the event. Let's see. Next. Yeah. So one of the last things is also with the addition of the recording stream or JFR event streams that was added in JDK 14, it's now actually practical to use JFR within unit testing purposes. So as you can kind of see here, oh, sorry. One last bit when it comes to your event types, or when you're creating custom events. So you can see here, there's a lot of annotations. And most of the annotations are for metadata purposes. There are some functional ones like adding, oops. Should be in there. Well, there is the enabled annotation, which obviously takes true and false. And by default, it's true, so you don't have to add enable in there. But you can also have it by default be false if you don't necessarily want that event type on all the time. Yes.
Hi, my question is JDK JFR event, right?
Yes.
Why it is a not an interface and it is a concrete like abstract class? And then I have to think about whether it is a thread safe or not.
Well, so part of the reason why it is a class and not an interface is like when it's calling begin and end on it, that's actually going to have behavior that's going to be communicating with JFR to actually be executed, as opposed to interface where you wouldn't necessarily have that. Huh? Yes. But back to the annotations is you would want to make sure, like, if you wanted to really be useful, you would definitely want to provide annotations. So for example, name, the default name would just be the fully qualified class name. But you would probably want to put, so all the predefined JDK events have JDK dot and then the event name, which, you can see here if we were to, all of these have JDK and then the event name. So that kind of, so like that first part could just be like your organizational name. So, it'd be my org, or in this example, I have like NYJavaSIG. That way you can define out the difference where these events are likely propagating from. And then from there, again, for your other developers, you may want to provide a label that can be a bit more descriptive, and a description that can be even more descriptive. And then there's also categories. And this can be a way for when in the tool, going back to JDK Mission Control, we went to the event browser here, and we went to my events. You can see here that it's separated these out by directories in here. And also, if I was to do JFR, I think categories, performance. Oh, got print. So yeah, I mean, again, just because my event only executed one time, that's the reason it only came up once. But this can be ways of, again, separating out these event types, so where you can again, more easily find them or more easily associate them together. But yeah, the last item wanted to then cover is with the addition of JFR event streams, you can also, yes.
Yeah. Can you go back to where you were using this event in the code, in the business
Oh,
code?
yeah, absolutely.
Yeah, like there was quite a lot of code, whatever, begin, end, commit. Like,
Sorry, 1 second.
can it be just an annotation? And I don't want to write any code other than add the line to my method with annotation.
Oh, so could it just be some sort of like annotation,
my
like
event, yes.
JFR event or something?
Or whatever, my event, something, JFR event, my event. And I wanted to do begin, end, and commit, and I don't want to write this every time.
You can write your own annotation.
Yeah. I mean, that's fundamentally what you would probably need to do is write your own annotations to then wrap around that method to do that behavior. But yeah, I can see how from a visual perspective, this is quite noisy. So, if you are planning on trying to cover a lot of different classes or there's like event type that you wouldn't be widely using within your organization, yeah, you would want to probably write an annotation that, as to was mentioned earlier, using like aspect-oriented programming that can then automatically wrap those method calls or something with that event type, so you don't have to write the begin and end and all of that within it. Yep, absolutely.
I have a
But yeah.
question.
Uh-huh.
How does JFR compare to App Dynamics or Dynatrace? I mean, they also do such instrumentation, right?
I don't have really enough experience with like app dynamics and that stuff. Like, I remember kind of using it a couple of times, like a long time ago before I was using JFR, and it's been so long I can't really give a good comparison that's meaningful. So I don't know.
Might be the built-in one.
What was that? Sorry, or do you want to?
Is it a built-in one, right?
Yeah, it's built in.
Yeah,
so,
those are third-party one. App Dynamics, Dynatrace, you have to install it, buy it.
Yeah. I think I think they'll probably like build when they're getting stuff out of the JVM, like they're using JMX endpoints or something like that to get that data. So I mean, a lot of times it's probably getting this same data, but they're maybe adding some other event and information into it. But I mean, that's just kind of be speculating on that. It's been a long time since I've last used those tools. Yeah, I mean, this does actually provide the whole stack as well, or you can provide as much of the stack as you want into commands. So, not within here. There's one example that provide. Yeah, this one's no, but it does actually also provide stack information. So here we go. I think this. Well, it definitely does. I can't remember what's some of the views, but it will provide a view on. I'm pretty sure maybe there's this. It's not coming up for me right now, but it will provide a view into like maybe a lot of times where like integer is being instantiated or something, and it provides a stack to say like, okay, this is where this method is being. So okay, here we go. So yeah, if I go do a lot of stuff here, it's providing the stack for that it's being called within Oracle JFR controller. That's being called by that, and so on. So yeah, this also provides a stack trace as needed. I mean, this should as well. So like the events when executed. So like here, like the event is also, I'm not capturing the stack in this my event type, but it provides the time as well. So if I was to find some of the events associated, it will provide it. In this case with JDK Mission Control, it's just not visualizing that data right now, but that data is actually being always captured. Because when you're calling begin and end on the event, so even the predefined event types. Like if you go into actual code, like you'll see the begin and end, and that's obviously the capturing the timing of it based on the JVM timing. But yes, sorry, back to the last part is you can also use JFR within your unit testing if as needed. Yeah, let me get to this last part for this prepared part of the presentation, and I'll be more than happy to answer your question. I just want to show it off. Or actually, I'll show it actually failing just to show that, you know, it actually is working and capturing the events. So yeah, this time it failed, and it failed because I misnamed the event type. If I was to name it or use the correct event name, so NYJavaSIG my event, NYJavaSIG my event, and then rerun this test. Name ignore, not a valid. Okay, I don't know why that was working previously. The joys of live coding. Okay, so now it passed. And so pretty much what's happening here is I have an array list. I'm opening up a recording stream with JFR. And so the recording stream is where events are propagated to by JFR. And I'm saying, okay, if an execution of my org event occurs, then add it to this array list. And then here I start the recording stream. I execute the code that I'm testing. I tell the stream to stop, and then I go into array list, and then I can inspect that event type to make sure that, you know, whatever is executing correctly, or it's getting the correct behavior. So like another example could be if like I'm capturing, like I'm reading from a file, and there's like the JDK read file event, like I can make sure inspect that happening, like I'm reading from the correct file or something like that. So yeah, that's it. And you had a question then?
Yeah, and my question is about stop the world. Does stop the world stop the flight recorder?
This would stop the event within this, or the flight recording within this event. And that way it flushes all the events from the stream. So that way it would actually then be captured by a list that I'm having executed. So, yep.
We have a question from someone from Brazil watching from the internet.
Oh, wow.
It's a super easy one.
Okay.
Can you put the slide back up that has the link to the PowerPoint for the prepared part?
Absolutely. Oh, there we go. Oh, for the PowerPoint.
Slide before had a link to
the PowerPoint. Link to the power.
Slide before the link beginning.
Oh, yes. Here we go. It's also this. Yep. Sorry about that. All right. Any other questions then?
Sorry, if there is an exception before end or commit, what happens?
So like if an exception happened here, or so yeah, like So yeah, like an exception happened at some point in between this code. Throat exception. Then that wouldn't be captured by JFR because the commit was never occurred. So probably what you would want to do if there is that concern for that happening in your code is then wrap it in a try and finally to make sure that the commit is always called. So if this goes out of scope without commit or end being called, it will still be garbage collected. It won't just be sitting out there that could be like a dead object that can't be memory collected or anything, or garbage collected.
There might event object, no? in the configuration you set the threshold with the time, no?
Yes.
Is it possible to monitor an object or any DTO, any Java object with the threshold about the memory? I mean, can I monitor if, for example, suspect memory leak, for example, if there is an object which takes so much memory, I mean, more than
No, to my
threshold.
knowledge, there isn't. The threshold is only by time. There isn't anything by memory size. The only thing with memory size is within the configuration. I think there is something. I think it's like data type or something. To where if you're capturing data type, that could be like time or data or something else. You can say like, okay, this is that number is like you're capturing like it's a billion and it's a data type, so then it knows to convert that to be like, okay, a billion, that's going to be 1 gigabyte in size. But as far as a threshold for data type, I don't believe that it's only by time.
I think if you take thread dump or heap dump, that will give you number of object and sizing. That will be better.
Yeah. So yeah, it doesn't have that. Within JDK Missile Control, there is a way to connect to, and this quite isn't answering the question, but at least it's somewhat similar. Is you can set up triggers within JDK Missile Control to where if you get over a certain size, again, it's not getting to a specific object or a specific event type, but at least, yeah. A way of getting a warning if hitting some sort of memory point. All right. Any other questions? And let me go back to the slide just so people have access to that link. Oh, some minor self-promotion. So on our YouTube channel, I have like some series of videos I call Stack Walker, where I kind of go into the underlying implementation details of various tools, mostly within the JVM. And I did one episode on JFR. So earlier on, when I had that PowerPoint slide deck kind of showing how events are written out from JFR, and then it makes its way to actually writing to a file. That's from that video. So you can kind of check it out. It's about 15 minutes long. And again, it gives you a bit of the history of JFR. And again, the underlying implementation details of like what is actually happening, kind of like also like all the data that's included within the events when they're also being captured by JFR, and kind of what that information looks like when it's printed out, and a bit more of the details like I was showing with like a custom event type, how that stuff is captured and the important parts of the information of the event type. All right, well, great. Thanks for having me. And again, if you have any questions, feel free to email me at billy.com.
Thanks, Billy. Before we do our raffles, thanks again to Bank of New York Mellon. And thanks, Oracle, for the pizza.
Absolutely.